Coming to the third category that we'll be seeing under chain growth polymerization, so it is cationic polymerization. Now we have seen free radical, we have seen anionic, now we'll be seeing cationic polymerization. Now, as the name suggests, cation, that is positively charged ion, will be the intermediate. So we have to proceed with this reaction. That is, we have to form from this monomer a polymer which will look something like this. Now, to proceed with this, here the initiator actually is an H positive, that is a proton. So initiator over here, in the previous two cases, they have initiators like peroxide and butyl lithium, but in this, we have the initiator as an H positive ion. So now, if we proceed with the reaction, so the first step that we observe is that this H plus will be reacting with our monomer, that is CH2 double bond CH with a group G attached. When the reaction proceeds, we'll be seeing that H is attached to the CH2 and the positive charge is now on this particular CH with the group. When this happens, it will again react with the monomer species, that is CH2 double bond CH with the group G, and as the reaction proceeds, we know that it will lead to the formation of CH3CH. The positive charge will shift to the next monomer that we attained, and it will be CH with a positive charge and a G group. So in this particular one, if we keep on repeating this, we will finally get a species which will look something like this. So we'll have CH3 CH with a group. Furthermore, we'll have CH2 CH with a group, and there'll be n units of this because we have performed repeated polymerization, and we have this. Now we have to remove, so we have to remove this particular initiator, that is the positive charge from this. So what we do is we just eliminate a proton. So elimination of proton has to take place. Now when we are eliminating a proton, what we'll do is that we'll just, so now we are representing this H here. Now what happens is that the bond will break from here, and this bond will shift here, and we are releasing an H positive. That is, this H is being removed from the chain, and therefore the species that we will obtain after the removal will be CH3CH with a group G, followed by the end units, that is CH2CH with a group G, end units of it. Since this H gave its bond to us, so there'll be a double bond over here and followed by CH with a group. So we have got this after the termination of the chain. And here also, since we know that the intermediate was a carbocation, so here the intermediate was a carbocation there because there was a positive charge being formed over here again and again. So the intermediate being a carbocation, and we know that the group which is attached to this intermediate is directly affecting it. So if we take some examples, say CH2 double bond CH, and we have Cn in place of the group, or say that we have CH2 double bond CHO C double bond O CH3. So what happens is, since intermediate that we obtained was carbocation, as you can see here, the positive charge that is attached over to this group, so this group will directly affect this particular intermediate which is of a carbocation. So now if we see this group, if Cn is the group attached, now Cn we know is electron withdrawing group, and therefore it will decrease further the number of electrons and will increase the positive charge. So in turn destabilizing our intermediate. So we don't want this. So the reaction will not be favorable if this is the monomer. Next, if we have this OC double bond OCH3 group, now we know O over here, the oxygen is giving a plus M effect or showing a plus M effect, due to which it starts to donate electrons, which will lead to the stabilization of the carbocation, and therefore the reaction is very, very feasible if we go through this monomer. Now, the next one, if let us say that we take another example, if we take another monomer, say CH2, CH, and now we have C double bond O followed by an OCH3. So here we have C double bond O, and C double bond O group as a whole is electron withdrawing. And we don't want electron withdrawing group, as electron withdrawing will further destabilize our carbocation. The fourth example that we'll take is again of CH2 double bond CH and phenyl group being attached. Now we know this phenyl group, because of the resonance, will stabilize the positive charge, and therefore the reaction will proceed if this is the monomer. So here we have seen, if a question is asked that all type of polymerization, be it radical, anionic or cationic, is favorable by which of the polymers, then we know that the answer will be styrene. So styrene, all types of polymerization are favorable. All types of polymerization are favorable. And by all types, here we mean radical by radical mechanism, be it by anionic mechanism, or lastly, as we have just seen, the cationic mechanism. So all these three types will be given by styrene. So styrene here becomes a star monomer for us. Okay. So these were the type based on chain growth polymerization.